Hello, pre-calculus students and particularly seekers of truth. We will continue our lesson on solving exponential equation. And once again, these are equations with exponents that are variables. And before we go on, we're talking about fractions, exponential fractions, and negatives. And so just to recap, to review a little bit, this is from Algebra 2, that a number to the negative first is equal to 1 over that number, right? So there's some proofs that go into this and some deeper explanation that we've done already in Algebra 2. So I'm going to move on. If you still have questions on this, I'd be happy to answer them in class. And there's the one caveat that y cannot be 0, because if y is equal to 0, you end up with a division by 0. Okay. So using this idea here, we're going to be able to solve these problems. So you see over here, I have 5 to the negative x on the left side, so I can rewrite this as 5 to the negative first to the x equals 1 over 125. Now, 5 to the negative first is really just 1/5 to the x. And on the right side of the equation, what I'm going to do is separate this into 1/5 times 1 over 25. And the reason that I'm doing that is because I want to get the same base on both sides of the equal sign. Okay. So I'm going to go one more time. This 1/5, the first 1/5 here, I'll leave it as is. Now the 1/25th, I'll separate that into 1 over 5 times 1 over 5 again. Right. And so what I have on the left side is still the same, 1/5 to the x. On the right side, this is really 1/5 times 1/5 times 1/5, otherwise known as 1/5 to the third. And that's equal to 1/5 to the x. So that means now that we have two bases that are identical, the expressions are still the same, so that the exponents must also be identical. So this gives us a value that x is equal to 3. Now let's see how we can apply the similar ideas to the number 4 here, where we're dealing with a fraction that's a base and a whole number on the other side. So instead of what I'm going to do here, instead of saying 1 over 3 to the x, I'm going to apply this rule here in kind of the reverse direction from the right side to the left side. Instead of 1 over 3, I'm going to say this is 3 to the negative first is equal to the x is equal to 81. Right? And then I'm going to multiply the negative 1 and the x, because that's just a property of exponents. And now I'm going to take this 81 and split it into groups of 3 as much as I can. So 81, we know, factors into 9 and 9. And then those 9s, they factor down even further to 3. Each of the 9s gives you 3 times 3. And so we have here 3 to the negative x is equal to 3 times 3 times 3 times 3. So 3 to the negative x, and I can remove the the parentheses at this point. So 3 to the negative x is equal to 3 to the 4th. So that tells us then that negative x, we can compare the exponents now. Negative x must equal to 4. Multiply both sides by negative 1, and x must equal negative 4. Right. So there you have it, a couple of examples on how to work with fractional and negative exponents.